This video is about number 3 in the notes. In this particular function, we're going to start once again with the parent table, and we're going to go ahead and transform it. We're going to look at our input and look at how that's changing. And once again, we're going to try and undo what's happening inside there. So our theta is being multiplied by pi over 4. And so to undo that, we would divide by pi over 4, which is the same as multiplying by the reciprocal. It's the same as multiplying by 4 over pi. So I'm going to come over here and I'm going to multiply each of these by 4 over pi. And what's going to happen is that you'll notice all the pi's cancel out. So if you look at your coordinate plane here, you'll notice that on the theta axis, the horizontal axis, there are no pi's like they have been in most of the other ones. So that can happen anytime if the number that you're multiplying by in front here, if that has a pi in it, it's going to cancel out the pi's in your theta. And so you're just going to have your theta values are just going to be whole numbers here. So let's simplify the rest of this. Again, we're going to do 4 over pi times theta. That's what we're doing. So if we multiply here, we can also cross cancel that one, and it's going to give us a 2. Oh, sorry, let's do the first one. I'm sorry, 0. And then we'll have a 2, and then this one's going to be a 4. This one's also going to cancel. It's going to be a 6. Again, you'll notice there's a pattern here, so the next one has to be an 8. Then we're going to look and see what is going on with our output. Our output, we're just multiplying the cosine by 5. So we're going to take our previous outputs that we've already calculated before and just multiply those by 5. So that part's pretty straightforward. And then go ahead and plot those points. And you want to try and draw this. It's going to be a little challenging to try and make it curvy, but do the best you can. And then you can continue that pattern through the rest of the coordinate plane. You want to make sure that all of your kind of curves, hills and valleys here all kind of look more or less the same size. If one looks much larger than the other, then you messed up your scale. The domain is all real numbers. The range, your lowest y value is -5, your highest y value is 5. Your amplitude, once again, here's your midline. You're going up 5. And your period, you're going from 0 to 8. 1 complete cycle, your period would be 8. Again, with all of these, you want to think about what transformations are happening. And this is similar to what we did last time, where you can look at your equation for sine. You can do a similar process with cosine, and you can figure out your horizontal and vertical shifts, your amplitude, and your period just by looking at the function. So again, the amplitude is always going to be the absolute value of A. It's going to be that whatever the number is in the front of the sine or the cosine. Your period, you're going to take 2 pi divided by your B value, the number that's being multiplied by the theta. Your vertical shift will be D, whatever is being added in the front, or it can sometimes be added at the end. And your horizontal shift is going to be your C value, whatever is being added or subtracted from your theta.